Hi, my name is Prasenjit Sarkar and I am a Senior Principal Product Manager for Cloud Native Applications. And today I'm going to talk about Oracle functions. This is a safe harbor slide and let's look at the objectives here. After completing this lesson, you should be able to describe Oracle functions. You should be able to describe the integrations of functions with other Oracle Cloud Infrastructure services. You should be able to create an application. You should be able to create a function. You can bring your own Docker file to run a function, and you can run a function triggered by Oracle Event Services. So let's look at the cloud native and four different pillars of cloud native and the different services that can cover to cater into those four different pillars, right? So the first thing first is the adoption part. And then we'll talk about the build part. The third is the deployment part. And the fourth is the operate part. Okay. So on the build part, as you can look at in here, the first thing first is how do you deploy a cloud resources, right? So you need to have a console. Okay. The second one is the quick start guide, because for the first time when you come in and then you start deploying those infrastructure, you need to have a base point, and that's the quick start guides. The third one is the SDK and CLI. So we have a rich SDK and CLI options. And recently we have released the TypeScript SDK as well. Then comes the marketplace where you can get open source softwares and other partner software as well. And then the last one is the always free tier. In the always free tier, you're going to get two VMs, and one, and you're going to get one load balancer, and a couple of GB of storage as well. On the second one, which is the development part or the build part, we are coming up with this API design. Now we already have Cloud Shell. Cloud Shell is to run command line and to maintain your infrastructure. You can use Cloud Shell. So it's a built-in browser-based kind of a shell where you can run OCI CLI, you can run various different programming languages, and you can authenticate without carrying any specialized keys or fingerprint, and you can do that. So that's about Cloud Shell. We are also working on this source control, which is similar to like your GitHub. It's nothing but an SCM. We do have a container registry, which is OCIR, or Oracle Cloud Infrastructure Registry. So this is all about where you store your containers. Then we do have a resource manager, and in the resource manager, you use that to upload your Terraform code, and then you run that, you plan it and run it, and to create your infrastructure on OCI. Now the third building block on your developer services portfolio is the deployment part. So deployment part will come down to the bottom. Now the first thing first, container engine, or the OK, which is nothing but your Kubernetes engine. Then it is your functions, so you can run FN. You do have streaming services. We are also working on the CI/CD part, and the last one on the top is the API gateway. And this is how this is what you use to expose either an application which is hosted in here, or an internal application which is hosted in here, right? Either on the functions or on the container engine side. Now the operate part, or the kind of a day two operations, things like that. So first thing first is the monitoring. So you can use Fluentd, in the logging services, event services, notifications, and email. Okay. So that's about these four different building blocks of the cloud native services product portfolio. Okay. Now, in my next couple of slides, I'll be talking about the functions and the building blocks of the Oracle functions, and then we will start doing deep dive onto that. Okay. So Oracle functions, it's a function as a service. It's a OCI integrated. It's a container native and an open source engine. And this open source engine, what you can look at in here, is coming from nothing but our own FN project, and it is secured by the realm of IAM. Okay. And it's a pay per use. So it's a pay for your execution, not the idle time. It's autonomous, so it performs the auto scales functions and no service to provision and manage, and of course no lock-in. It's completely built on the open source FN project and Docker. All right. So how does it work? So first thing first, you need to push the function image to the registry. So you build your function locally in here. This is your local desktop, and here you use FN, and then you build the Docker image, and then you push it to OCIR, and then you configure the function trigger either manually or via the integration of our events. Okay. Code runs when that is triggered. It can be triggered via manual or via the external factor, which is the event services, and pay for code execution time only. Okay. So it is based on FN, which is an open source functions platform, and you can look at in here fnproject.io, and that is something that we are working on. It's an open source, there's no vendor locking. It's a platform independent, so you can run your development on local laptop or on the server or on the cloud, or you can do that on OCI Cloud Shell. And I'll show you how do you do that in my demo slides. Okay. It is approachable, easy for new users, low-level controls for the advanced users, and it is container-based and use Docker. So that means you can bring your own Docker file and you can run that as a function. Okay, I'll show you how do you do that and what are the advantages and disadvantages of that. Functions equals to containers. So these functions are packaged as containers. These package, and you can use the open source libraries as functions, and you can use Python, you can use Java, Go, Node.js, Ruby, GraalVM, and bring your own Docker file. Okay. So if you are using a function and if you know that that's how it should work, then you can bring your own same Docker file from other platform and you can run it on here. Okay. Now let's talk about the integrations of FN or the functions with other OCI services. So first things first, the event services, right? So let's look at the event services. So in the event services, if you upload, let's say, a file to your object storage or to, let's say OCI object storage, and based on that, you want to run some functions to, either replicate that, or let's say you want to version that, or let's say you want to run some amount of code on top of that file, you can do that using that event services integration. Okay. Notification services integration is upcoming, and then you can expose that via the API gateway. So this is all about how you can expose that function, which is again running probably in a private regional subnet, and other Oracle integration, and then the OCI, CLI, and SDK. So this is all about the triggering part. Okay. On top of this triggering part, you have this image, which is going to be residing in this OCI registry. Then you can pull this image, and of course, push and pull is happening in here. And this is your FN box, which is hosted by us, and this is how we are going to give you the execution time. And then you can send the logs and metrics to the monitoring and the logging services. Okay. And in terms of the use, you can use these, which is your object storage. You can use autonomous database, and I'm going to show you how do you do that. You can use the key management services or KMS. You can use compute, you can use network, and various different other services. Okay, so let's look at the API gateway and how do you expose that, how do you expose your Oracle function using API gateway. So API gateway is a REST API for OCI services. It allows Oracle functions and the Kubernetes services to be exposed by the API gateway in here. It can also use HTTPS backends as well. Okay. It does have routing, the rate limiting, CORS, custom authentication, matrix. It's fully Oracle managed, and we do have the Terraform code for that as well. There's regional OCI services, and the GA is already been done. Okay, so we have this API gateway, which we are going to use to expose a function which is deployed on top of a private regional subnet. Okay, let's look at the architectural side. So here you see that from the internet, a call is coming in. Now, of course, you have these DNS services to resolve the name. You have WAF to protect that from the bot. You have the DDoS protection as well. And then you have another layer of protection, which is OCI security list and the security rules on top of that. And then, of course, the routing table, which is going to help you to get to the particular API gateway. Okay, so now this is my VCN, right? And the call is coming in here, and it is going to hit the API gateway. Okay, so once it hits the API gateway, now the way the API gateway works is that it can connect to the private regional subnet, what you can see it here, or it can connect to a public regional subnet. Okay. So think about a private regional subnet where your function is running in here, and it's going to hit the load balancer, and then the load balancer is going to hit in here and to take that function and then expose it outside from here. Okay, and of course this same function can talk to your ATP database to perform some database operations in here. Okay. So that's about how an API gateway can be used to expose the Oracle functions, and I'll be talking about it more, and I'll show you how exactly you do that in my demo section. Okay. In the next slide, I'm going to show you the event services. So of course it is real time. It's an event alerts, and you need to write the rules to track the changes of your cloud resources using the open standard Oracle event services. So it tracks the user initiated system and resource lifecycle changes. It allows an admins to define rules and actions for event types. It integrates with the Oracle streaming services, notifications, and functions in here. Okay, it's an industry standard event exchange format, so you should be able to get that same format what you are used to and write that same rules to act on it. Okay, so what are the use cases? So event services use cases. So let's look at a use case where you can use that to do some operations, right? So here it is your Oracle function. Okay. You can have an event-driven apps. You can have a CNCF compatible cloud provider because it's as I said, it's an open standard. You can send an email notifications and HTTPS notification, which is going through the let's say PagerDuty, and this is all about your notifications, right? And then you can send it to a stream. And for the stream, you can have, let's say, a security incident management. Let's say you can send the data to the Splunk. Okay, so that's about your event services. Send the events, and based on that, you are acting on it. Okay, using either notification services or FN services or the streaming services. Okay, so it can support the compute services, the database, VCN services, block storage, object storage, key management, and IAM, and compartments, and the resource manager. Okay, now let's look at the use cases in here. Let's look at a couple of use cases. So customer use cases, event-driven governance. You can run web or mobile middle tier. You can run real-time file processing or a machine learning or a DevOps. Okay, let's look at a use case first. So it's a first use case where we are talking about enforcing corporate security policies and governance rules. The goal for this use case is to ensure that all user provisioned cloud infrastructure complies with the corporate security policies. The solution is you need to define a set of audit functions that validate the configuration of different OCI resources, which is, let's say, your VM, your network, or your database. And you define the OCI event services rules to trigger the audit functions on creation and configuration change. And the audit function tears down the resources that doesn't meet corporate security policies. Example is if a compute instance has a public IP, then terminate that instance, right? And this is how it should work. So you have various different resource type, which is the resource change events should send that event to the event services too. And then on that, you use Oracle functions to run that, okay? And you use that to send it to the Oracle functions, which will take an action on top of it. So either it can audit and tear down all non-compliant resources, example, shutting down your compute instance if it has a public IP address, okay? Let's look at the second use case, which is ingesting and access logs in security incident management. The goal for this use case is to ensure that all access and audit logs are sent to a centralized security incident management system like Splunk. So the solution is OCI network flow logs, or called audit logs, or audit logs are updated to the OCI object storage buckets at regular intervals. Then you define a function to parse those log files and post the log data to the customer Splunk instance. And you define the OCI event service rules to trigger the function on creation. And then functions process the log and send the data to the Splunk, right? Let's look at the architectural pattern on this. So this is your VCN where you are monitoring the flow logs, right? And you are sending that flow log data to the object storage. Immediately upon getting the object storage file creation event, right? So you create the file, and based on the create event, it's sending and signal to the event services. Event services sending the rules. Based on the rules, it is sending that event to a function, and a function is running to parse that access logs and store that data to the Splunk, or let's say ELK. Okay. All right. In next couple of slides, I'm going to talk about the behind the scenes matters. So what happens when you deploy a function to the Oracle functions? Okay. Now, when you have written the code to a function and it's ready to deploy, you can use a single FN project CLI command to perform all the deploy operations in sequence, which is building a Docker image from the function, provide a function definition in a func.yaml file that includes the maximum length of that time of the function it is allowed to execute, for the maximum amount of memory the function is allowed to consume, and then pushing that image to the specified Docker registry, and then uploading that function metadata, including the memory and time restrictions, and a link to the image of the Docker registry to the FN server, adding that function to the list of functions showing in the console. Okay. Now, let me just start drawing it and see how exactly that happens. Okay. So first thing first, it builds a container image, which is a multi-stage build. That means bumping the version. So every time you run the build function, it is going to create a Docker image and it is going to bump the version, right? So this is your code, and your code resides in my func, let's say the second iteration, which is 0.0.2. Then you push that code or the container image to the registry, which is your OCIR in this case. And then your function, which is your myfunc, is consuming this myfunc 0.0.2 and then sending it to create and update the metadata or the function metadata, right? Now, what happens when you invoke a function? And this is something that we really need to understand. When you invoke a function, there are various different sequence of task that gets executed. You can invoke a function that you have deployed two Oracle functions from number one, the FN project CLI, number two, the Oracle Cloud Infrastructure SDKs, number three, sign HTTP request to the function invoke endpoint, and every function has an invoke endpoint. And other Oracle Cloud Infrastructure services, for example, triggered by an event in the event services or from external services. So when a function is invoked for the first time, Oracle Functions first verifies the request with the IAM services, assuming that the request passes the authentication and authorization checks. It then passes the request to the FN server, which uses the function definition, which is been stored in the func.yaml file to, number one, identify the Docker image of the function, to pull from the Docker registry, to execute the function by running the function's image as a container on an instance in a subnet associated with the application to which the function belongs, right? And that is where you will deploy your function, okay? Then when the function is executing inside the container in here, the function can read from and write to other resources and services running in the same subnet. For example, your database as a service, okay? And an object storage, let's say, okay? You can specify the maximum length of the time of the function allowed to execute by setting a timeout in the func.yaml file or in the console, okay? And that's how you control the cost of running function as well. Oracle Function stores the function's logs in OCI or in the external logging destination. So that is something that you can configure it. So you can send, let's say, to Logly or any other open source logging provider and access that log there as well. So when the function has finished executing after a period of being idle, the Docker container is removed. And if Oracle Functions received another call in the same function before the container is removed, the second request is routed to the same running container, okay? So if the Oracle Functions receive a call to a function that is currently executing inside a running function, it scales horizontally, okay? As I said, it scales horizontally. So you can have, let's say, one function, one container in here, then another container, another container, another container. If the same, so these are all my container images. And let's assume that you are getting a call to the same function again and again, even when the function execution within this container is still happening, right? So you can just start creating it horizontally, okay? And that scales horizontally to serve both the incoming request and a second Docker container is started, and it shows the information about the functions invocations in the matrix chart. So it sends the data to the matrix server where we store the number of times the function has been called and executed. Okay, so that's what happens when you invoke a function. Now, the second thing that you need to take care of is your file system. So a function you have deployed to OCI can access the file system of the container in which it is running as as follows. Let's look at that. So the function can read files from all directories. Okay, so from all directories means I'm saying from slash. So I can do read of any files anywhere in slash. The second thing is writing. So the function can write files only to slash tmp. Okay, remember this. You can only write the file into slash tmp. Okay, so for example, you might want a function to download an Excel file and read its content. To meet that requirement, you might create a function that writes the file to the slash tmp directory in the container file system. and then subsequently reads that file. So when writing the files to the TMP directory, the TMP directory is generally always writable. However, the maximum allowed size of the /TMP directory depends on the maximum memory threshold specified for the function. So when you create that function, you specify the memory, and based on that memory, the maximum allowed size of /TMP should be defined, right? So be very, very careful about this. So maximum memory, let's say starting from 118 MB. So if you specify the 118 MB, so your maximum allowed size of /TMP can only be 32 MB. So if you are downloading a file of, let's say, 40 MB, it will fail. Okay. And this is also the number of files. Let's say you do not create that kind of in a huge file, which is like 32 MB. But if you want to create more than 1024 files, which is, let's say, you want to create 1200 files, right? Small files, you are not allowed. Okay. So you need to bump up that to 256 MB of memory. And if you do that, you're going to get 64 MB of maximum file size. And for the 512 MB, you're going to get 128 MB of file size, and 1 GB of memory, you're going to get 256 MB of file system size. Okay, maximum allowed size of /TMP. And then in here, you can get 8192 number of files. All right. So you need to be very, very careful about how exactly you're writing the code and how exactly you want to do that. Now, in the next one is the container runtime permissions. And this is particularly for when you want to bring your own Docker file. So BYO Docker file. Okay. So when you want to bring your own Docker file, let's look at that. The kind of behind the scene what happens. So when a function you have deployed, an Oracle function, is invoked, it runs inside a container. The operations that a container can perform are determined by the user ID and the group ID, the UID and the GID. And here you can look at this GID and UID, right? So if a UID or GID is not specified, the container runs the processes as the root user. That's dangerous. So that means if you create a Docker container and let's say you are downloading some sensitive data and you upload it to a registry which is publicly accessible, and you want to you want people to download that, and if they can run that same container into their laptop, and if it is not set by the UID and GID, they can be a root, and as and when they are becoming a root, they can access all of the files, including your sensitive files, right? And that's dangerous. You shouldn't be doing that, right? So with all the default permissions in our build, on the root user should be able to do anything and everything they want. Okay. So when starting a container to run a function, Oracle function always specifies a user name named as fn with a UID of 1000 and a group name called fn with a GID of 1000. So the container and the function that running inside it does not acquire the default capabilities, right? So here, as you can see, that we allow group add and add user with a UID of 1000 and called fn, and GID of 1000 called fn. Okay, and that's how exactly we need to add it. Okay, so in addition, the container is prevented from gaining the privileges. As a result, you do not create and deploy function that depends on the capabilities that are unavailable, which is there in the Docker documentation, or depend on the privilege elevation, for example, SU or sudo or SUID. So those are not possible, right? And if you run that, so if you are bringing your own Docker file, so this is my own Docker file, right? As you can see, from Oracle Linux 7 Slim, and I'm running, I'm just installing Oracle Release EL7 and Node.js and Oracle Instant Client and things like that. And I'm saying that workdir/function add, and I'm adding the code, and then I'm saying npm install, and then I'm running this function. When I do that, without having this GID and UID, it will error out. Okay. So when you bring that, always mention that you have to have group add and add user to this. Okay. You need to add or whatever the way that you want. I mean, this is a command line to add user and a group to the Oracle Linux 7, but based on distro, you can use your own command line to add a user or a group. Okay, but you have to do that. Okay, accessing other cloud infrastructure resources from running functions. And that is something that, as I mentioned in my earlier slide, that you can have your function accessing your other OCI resources, and how do you do that in a completely secure way is something that we need to look at. Okay, so to enable a function to access another OCI resource, you have to include the function in a dynamic group and then create a policy to grant the dynamic group access to that resources. For more information about the dynamic groups, including the permissions required to create them, you need to look at the IAM services. Okay. So your IAM services is your key factor in here. You create the dynamic group first, and then you create the policy to give access to the other OCI resources for the functions. Okay. Now, having set up your policy and the dynamic group, you can then include a call to a resource principal provider. Okay, and that should be done in your function code. So the resource principal provider uses something called resource provider session token, or called RPST token. You can look at it in here. So this guy sends an RPST token to the IIS services to access those services and send the calls to. Okay, so the token is only valid for the resources to which the dynamic group has been granted access. So that token which you are sending, it is only allowed to access something that you have written that dynamic group to. So if you have created a dynamic group, let's say to access only the object storage, so that RPST token is only valid for object storage and nothing else. And also you need to make a note that the token is cached for 15 minutes. So this token is cached for the first time for 15 minutes, right? So if you change anything on your dynamic group, and if you run the function again, thinking that it may happen, it may fail, because immediately it's not going to be used. So that RPST token does live within this infrastructure for 15 minutes. So after 15 minutes, the cache will be deleted, and then again a new RPST token will be generated based on the dynamic group, and you can get access to the services that you have written in the dynamic group policy. Okay. So we recommend that you use the resource principal provider included in your OCI SDK. However, you might be writing a function in a language that OCI SDK does not support, or you might simply not want to use the OCI SDK. In either the case, you can write your own custom resource principal provider to enable a function to authenticate itself with other OCI services using file and environment variables in the container in which the function is executing. All right. Okay, so that's about the behind the scenes that you should know about when you are bringing your code to run on Oracle Functions. For additional information, look into this functions overview.htm file. And listed in here is the link, and that's about it. And these are the couple of resources. So they are free tier, OCI training and certification links, OCI hands-on labs, and Oracle Learning Libraries videos on YouTube. This is where you can find our other videos on other topics. All right, thank you for watching. I'll see you in my next video, which is a function demo.